Hello, I think that we're going to start. Welcome everybody to this webinar. We are going to be jointly leading the webinar. I'm Emilia Moreno Ruiz, and Amir Safai. I will now shortly introduce ourselves. So as you can read this in this first slide, this webinar aims to be an introduction both to the SRI project, and this part will be led by Amir, and to ecoinvent version 3, and this is the part where I would be speaking mostly. For the structure of the webinar, we have organized it in 4 parts, and you can see in your GoToMeeting you are not, you don't have the right to do a handout, so you cannot ask questions live, but you're able to, and you're also, of course, you're allowed to type questions while we are speaking, and we will stop in a kind of mini wrap-up slide after every part of the webinar, and then we will collect the different questions and we will address them at that moment. If ever, because of matters of time or other reasons, we are not able to address all questions, we might try to answer them by email, or don't hesitate to contact us with further questions. So, that said, let me introduce you to the 2 of us that are going to lead this webinar. As I said, my name is Emilia Moreno Ruiz. I'm the Deputy Director of ecoinvent, and Amir Safai, who will be talking about the SRI project. He's our internationalization project manager. Let me start everything by introducing or talking a little bit about ecoinvent. ecoinvent, I guess that for many of you this is not really new information, but still, ecoinvent was founded by different Swiss institutes and institutions in the late 90s. The ecoinvent database was set up and it was ready and running and been functional since as early as 2002. And it has been one of the world leading LCI databases since. This is important thing to remember. ecoinvent is a non-for-profit association, so we don't have a commercial purpose. We are a non-for-profit association, and we do publish yearly updates from the new version 3 database. We of course also maintain in our database the access to oldest versions of the database as version 2, and but in the case of the version 3 we maintain and we enrich this version of the database with yearly releases. The most recent one, which is version 3.3, was published in summer this year, summer 2016. Just to clarify, this presentation aims to be more an operational introduction to version 3. It's not, and of course to SRI, but the part that concerns me, it's an introduction to version 3, and I will be then introducing you to the use of version 3 in our web page mainly. We are not going to touch how version 3 is implemented in different software, in different LCA tools. For those questions you might want to address your tool provider, or check in our web page how to do certain things. So let us start with some useful tips, and one of them is related to how can you use our web page in a more powerful way, I would say. There are some new functions in the web page, which is, it's a new web page. Well, it has now some months, but still it's new. We have this search function, which is very useful because with keywords you can find everything you need in our web page, also in PDFs or in PowerPoint documents. You can go here to the support tab to find information that you're looking for, and many places where you can find answers to your questions. We have frequently asked questions, we have a forum, we have several documents posted here. You can also go to the database tab. This is also an interesting tab that allows you to explore more on the database, on version 3, or on the system models. And finally, let me please insist on this button, which is the login databases button. This is where you have to go to have access to our databases through our web page. You can have free access as a guest, and you can have free access to the multi-output and allocated uniprocesses of version 3. This is what we normally call the undefined database. This access is free. You can go, connect, and have a look at our database, how it does look like. You also have free access to reports, version 2 and version 3 reports. If you connect yourself as a licensee, so you hold a license from ecoinvent, you will have access to all system models in the version 3 and also to older versions, which are always there and accessible, version 2.0, 2.2, 3.01, 3.1, 3.2. Just to finish, this is also a recent feature we have developed. We, as I was mentioning, we keep and we maintain the version 2 reports, which are still very useful for many aspects. We are more and more creating a richer library on version 3 reports, but we wanted still to enhance and to facilitate the access to complete documentation as per dataset. Because in version 3 we have worked a lot on activities that were fully documented and that could be independently seen and understood. So we have developed this function, which is the possibility of downloading each dataset in each of its formats as a PDF report. You can see here, this is an example I have done a screenshot of a dataset in its undefined version, so the version that you can download actually for free, of version 3.2. So we have these PDF reports for any release of version 3. And you can see here in this PDF report, you can see all meta information, as you can see in the slide, but also all the exchanges, and in the case of a PDF report of a dataset in a calculated system model, then you can also see some privileged impacts, results from some impact assessments. So that's all about the introduction, small tips and small introduction to ecoinvent use. And let's start properly with what will be this webinar. The webinar will be divided in 4 parts, as I think I already announced. And this first part that it's starting now, it's about SRI projects and activities in Latin America, India and South Africa. This will be given by Amir Safai. And then we will have 3 following parts about understanding activities and products, understanding markets, and understanding the undefined database and the system models, which will be given by me. So without further ado, I can give them the lead to Amir. Please, go ahead.
Hi everyone, good afternoon or good morning depending where you're coming from. Welcome to this webinar from my side also. As Emilia kindly introduced, I'm Amir Safai and I am the project manager of the SRI projects and basically the internationalization project manager at ecoinvent. So I provide a brief introduction to the SRI project through this webinar. Just wanted to also mention that these webinars are organized as a part of the SRI capacity building programs, which I actually explained in over the next slides. So SRI project is a project that is funded and supported by the Swiss State Secretariat for Economic Affairs, which is called SECO, and has basically 3 different components being implemented by 3 different institutions, and it's an international project, so it's actually implemented in different areas around the world. So the 3 components of the SRI project, the one that interests us for this webinar is the lifecycle inventories project. That is a project that is implemented in Latin America, Brazil, Peru, Colombia, India, and South Africa, and the implementer is actually ecoinvent. There are 2 other components of the SRI project which are actually implemented by EMPA and the World Resource Forum, which actually for more information you can visit the website of the project that I will introduce over the last slide. So we go a bit into the detail of the lifecycle inventories project, the SRI project, and I explain the different components and the outcomes of the project, which will be finished by the end of 2017. So the SRI project, lifecycle inventories project, actually has two general aims. First is to increase the existing capacity for doing LCA and generating lifecycle inventories for a number of focus regions, and also generate and provide for free the lifecycle inventory data of a number of prominent sectors and industries in the regions. So as I mentioned before, SRI is active in a number of regions, including Latin America, India, and South Africa. In Latin America, we are focusing Brazil, Peru, and Colombia. And in terms of timeline, the project has started in the beginning of 2015 and is scheduled to be finished by the end of 2017. So we almost have a year to go to wrap up all the activities. The SRI project have different subcomponents, which I just briefly touch upon. So one of them is the regional coordinating centers, and as I said, the two other aims of the project is to increase the LCA capacity and expertise in the regions and the data collection activities. So as for the regional coordinate centers, we have contracts with a number of as we call it, LCA experts in the region that we call the regional coordinator centers in the region. The aim is for them to assist us to coordinate the activities of the SRI in different regions. So we call them the coordinator centers. So there will be the facilitators of the project in India, and of course they also, as experts in the region, they also carry out different activities in terms of capacity building and assistant also in designing some of the data collection projects and the scope of the project in different regions. In different regions, we work with different institutions. In Brazil and Latin America, we are working with Technical University of Paraná, UTFPR. In India, we work with Confederation of Indian Industry, and in South Africa, we are working jointly with NCPC, National Cleaning Production Center, and UCT, University of Cape Town in South Africa. As I mentioned, one of the main aims of the SRI project is increasing and enhancing the LCA and LCI expertise, or as we call it, the capacity building. So the main aim of the expertise and capacity building is to raise awareness about the importance of LCA and LCI, and of course develop the local LCA skills and LCI skills. So we have had a number of activities, capacity building activities, including workshops and webinar over the last year and since the start of the project. So we had a number of rounds of workshops in India and South Africa and in Brazil. We are going to expand this for the next year, and which I actually explain now in the next slide. So for the year ahead, we will also have a number of capacity building activities over different aspects and in different levels of expertise, and for people with different levels of expertise in LCA. So for this, actually, we are now coordinating with the regional coordinators to identify and pinpoint the capacity building needs in different regions. And after this process that is actually ongoing now, we will actually launch a number of capacity building programs over the course of the next year. The idea is that for the programs to be a mixture of different delivery methods, such as workshops, webinars, and of course they will be suited to the needs of different regions based on the perception we get from the region, and also the assessment we will do in the initial phases. All these activities that I'm talking about are free to participate, but of course we have limited space, so this is just an announcement of the program. I will also tell you about where can you find more information about the SRI project in general and our future activities. So as for the data collection and provision, that is one of the main aims of the SRI project. So the idea is to provide, to gather and provide the lifecycle inventory data of the major industrial and prominent sectors of each region. For this, we have a tier-based approach, saying that we want to gather the data, we want to have the lifecycle inventory data and provide the lifecycle inventory data of the main background processes. And what I mean by background in this case are the processes that are almost inevitably used in any LCA, including energy, like for example electricity, transportation, and building construction. So in all of these regions, we have a number of data collection projects which aims at collecting and providing these data. And of course, each region and each country has a number of strategic or important products or services in terms of, for example, contribution to GDP or contribution to the national emission or other criteria that we will, based on these, that we will also focus to gather and provide the data for these prominent sectors to this country. So there is also another aspect of the project which we actually try to employ and get use of the existing data that is the results of, for example, different LCA studies or projects that has been done by industry or different academic institutions. So all the data that we will gather through this project will be freely available to the local communities, and of course it will also be a part of the ecoinvent database for you to be able to use it over your software, and also to be connected to the other parts of the supply chain. And the benefit of this specific project is that all the data to be collected, since it will be a part of the ecoinvent, it will also pass the review process of ecoinvent, so we will also review the data according to our data quality guidelines and then provide this data for free for the local communities. On top of the data for being integrated into ecoinvent, we are also in negotiation with different national database initiatives in regions to also provide the seed for the data collected through the SRI, to provide the seed for these databases. So, for example, for the case of Brazil, we are in contact with SIG, and the idea is that the data that we collect through SRI will also be a part of SIG at a certain point, and after passing of course the review process of equipment. Just for you to have an overview of the different data collection projects and the sectors we are focusing on. As I said, our main aims is, of course, to collect data for the background processes. So electricity and energy are one of the main aspects here. So we have two different projects. We have different projects for electricity generation and distribution per state and grid. So that's the case for India and Brazil, where we are actually chopping or we are actually dividing the country based on the grid, based on different grids and states. So we will provide regional lifecycle inventory data sets per state or per grid in India and Brazil. We also have projects for other countries in Latin America and South Africa for the electricity data sets. We are also focusing on coal mining in India and South Africa, which are actually quite prominent sectors in both of the regions, as well as their contributions to they have, of course, undoubtedly significant amount of emissions, at least even in the upstream phase. Forestry and agriculture are prominent sectors for almost all of these regions, so we have a number of data collection projects in each of these regions for the collection of and provision of the data sets for specific products and crops that are produced in these regions. We're also focusing on animal husbandry in South Africa and in Brazil. Both are again quite prominent countries for these products. Textile and iron and steel are also other sectors that we are gathering data for the case of India. And building construction is also one of the sectors. We are collecting data for all the regions we are working with. So there's a data collection projects for Brazil, Colombia, and Peru, and two different projects for India and South Africa. They're all of these projects have already started or to be started by the end of this month, and are planned to be finished by the end of 2017. There is also another data collection project over the water about water supply and distribution. It's It will address all of the focus countries of SRI, and other projects on petroleum refinery and products. This is a global case where actually we are updating the ecoinvent database on a global scale, and also focusing on all of the regions and the countries that we are addressing through SRI. We also have two data collection calls that are actually already open, and you can see the format of the calls and, for example, deadlines. And these are actually the primary production of precious and scarce metals in South Africa and in Latin America. And I actually provided the link through these slides, and I think we will provide the slides after the webinar. So all these slides will be available. We can refer to the links later. Finally, through the data collection projects, and we are also developing a number of tools and models to help the LCI practitioners to be able to to generate lifecycle event data sets for sectors with high modeling needs. One of them is waste treatment and disposal technologies, and the other sector that we are having the same approach is refinery model and data. We are also thinking about developing other similar tools for other sectors with high modeling needs that we will actually announce the calls as I said, by the end of this year. So how does the data collection does the data collection works through the SRI? So all of the projects are announced through open calls for tender that are open to public to apply, and we publish all the calls on our website, and of course in terms of value and the funding for the calls, all of the calls they have funding. The value and the funding indeed depends on the sector we are talking about, the complexity of the data and the data we are required. And all the calls, most of the calls have been already opened and assigned to data providers, but we still have other few calls to open, and they will be finalized by the end of 2016. So well, actually, with this slide, I'm finalizing my talk about the SRI project. So overall, I hope I've given you enough information about the SRI project. If you need more information about the project, you can always check the website of the program, sustainablerecycling.org. As I mentioned, on ecoinvent website, we regularly publish the calls, data collection calls, and we will also announce all the upcoming capacity building activities for different regions. And any specific questions answered, I'll be very happy to receive your emails at my email that is mentioned here. So with this, and if there are no questions, which I don't know, and which actually Emilia will go over, I think I hand the talk to Emilia. Thank you very much.
Well, we actually got one question, but it's more about how to collaborate with this initiative and how to be informed and to enhance the building capabilities in certain countries. So I just send your email, and this is very in line with what it's also in this slide. So I think we can continue.
Okay, thanks.
So let's continue then this webinar, and let's now dive a little bit in the version 3 part. So in the second part of the webinar, which is now addressing the introduction to version 3, and it's about understanding activities and products as an entry door to understand version 3. So how do we define an activity in version 3? An activity will be a unit process that is representing a process and its exchanges with environment and with the products of other human activities with the technosphere. This is what we mean in ecoinvent version 3 when we talk about activities. The interesting thing about this is that activities, which are processes, are producing products. Activities are generating products, and the products are the outcome of the process is different of the process in itself. And there are two types of products that an activity can generate: reference product, which is the main product of the activity, and byproducts. And this dissociation between the process, so the activity, which bears a name, in this case the example I've been following, it's electricity production, hard code, and the outcome of the process, which is the resulting product of the process, in that case electricity high voltage as the reference product. This dissociation is typical, is a base of version 3, and it's an important change regarding if we compare version 3 and version 2. In version 2, the process and the outcome of the process will be bearing the same name if you were users of version 2. So this change, this dissociation between process and the outcome of the process, so activity and product, allows many new possibilities. For example, the possibility of having a systematic creation of consumption mixes for the product, or the possibility of finding different producers for the same product, or the possibility of defining substitution of a product. So as I just mentioned, different activities can produce the same product, different processes can result in the same product. And one of the consequences is, as I just mentioned, is that you can filter and group and search for same producers of the same product, and these same producers of the same, or different producers of the same product can be different because they have different geographies. Like in that case, we are following electricity production, hard coal in Australia, but we can have the same type of electricity production in Russia, and yet the resulting product will be the same. But the activities producing, different activities can be producing the same product because they are representing different technologies. Of course, there are various ways of producing electricity, and we have been following this electricity production with hard coal, but electricity can be also produced with hydro pump storage or nuclear or natural gas or many others. There's a special type of activity, or at least that causes more problems to understand to the user, so I would like to spend a little bit more time here, and those are what we call treatment activities. So treatment activities are transforming activities, similar as electricity production that we just saw, but in those cases the reference product has a negative sign, and this is normally what disturbs the users is the negative sign, so let's just focus on that. Why is this a negative sign here? So the negative sign is actually allowing us to represent that this activity is supplying the service of treating or disposing of this reference product, which is a waste normally. So let's try to better understand this, and then let's see how this treatment activity is working with the waste producing activity. Let's introduce this waste producing activity that will actually have a negative input of the waste produced, which is waste paperboard in this example. So this flow, the waste paperboard, the waste has been moved in the waste producing activity, has been moved from the output side where it was physically produced, where it was generated as waste. It has been moved to the input side, and using this sign change, so it has been moved from output to input side, and the sign has been changed, allowing us to maintain the mass balance within the inventory. And if you look, the same is done in the treatment activity, where the negative output is actually modeling an input, the input of the waste, that it's moved in a mass balanced way to the output side. So representing the fact of treating or disposing the waste, in that case incinerating the waste paperboard. So this way of constructing the inventories, this fact of using the negative sign, is allowing us to maintain mass balances, both in the waste producing activity and in the treatment activity. And then if you look at the whole treatment chain. So if you look at the interaction of the supplying treatment activity and the producing waste and the waste producing activity, if you look at the chain, the disposal, well, in this case, the incineration, the treatment of the waste has a matching negative sign with the waste generated in the waste producing activity, and this is situating correctly the disposal or the treatment of the waste upstream of the activity producing the waste. And then the two negative signs which cancel each other. This is important, it's in the slide, but I will insist the negative signs are only allowing us to model a waste treatment chain where the waste treatment is upstream of the waste producing activity in a mass balanced way. This is by no means changing the sign of your LCI results, for example. And if you're users of the version 2, the fact of organizing the treatment chains this way, it's not really new for you. So the waste treatment was modeled similarly in version 2. The waste producing activity were receiving inputs of the treatment for the wastes. The only difference that we can see now in version 3 is that we apply this sign change that, as I explained in the slide just before, is just allowing us to maintain mass balance within both the waste producing and the waste treating activities. So just to wrap up this part, and then we can address questions if they are. The database, so the version 3, is organized in activities that represent manufacturing, fabrication, production, construction, or extraction of products. Several activities, whether different geographies or technologies, can produce the same product, and this has a series of advantages, as we have seen. And the treatment of waste is modeled very much like in version 2, with an entry of disposal in the waste-producing activities, except that in the version 3, we use negative signs to allow us the maintenance of mass balance in the activities. So I would stop here, maybe can get some questions. So we got just one question, but it's more a concern about how to search for products or for activities in the database, or how to react when the product or the activity is not really available in the database. So this goes more into modeling. It's not really related to this, but yeah, I think that it's maybe better if we continue with the webinar.
Sure. Yeah, Emilia, we don't have any more questions, so maybe yeah, if for very specific questions, maybe we can ask the users to just contact us on the support directly.
That would be good. Yeah, I think so.
Thank you.
Thank you. Okay, so then let's attack the second part of the webinar, which is a bit longer than this first one, which is about understanding markets or understanding consumption mixes in the version 3. So similarly as the activities that I just presented now, which were activities transforming something into something else, the version 3 database also contains what we call market activities. Market activities are consumption mixes. Consumption mixes understood as a production mix, so what it's produced in a country, for example, plus the imports received from other countries minus the exports. This is a consumption mix, and this is what the market is representing. The markets, they also, so the consumption mixes, the markets, they are supplying a given product. So in that case, it's a market for electricity high voltage, and this market is supplying the electricity to the consumers. So it's transferring actually the electricity from the mix of producers to whatever consumer would demand it. There's also for users of the version 2, it's just as a reminder, there were also consumption mixes in the version 2. The difference of the version 3 is that this is now done systematically for every product. There is a consumption mix for every product. And that's the big difference in systematization. The market activities, they also add some information to the consumption mix. They will add information relative to transport and relative to losses, where if the losses make sense. In this case, we were following the market for electricity high voltage, so then we have the transmission network as an input to the market, and then losses in the transmission, which are modeled as ozone losses. Of course, market also exists for wastes, and similarly they will represent the consumption mix of the waste treatment, and they will also have transport information. They will have, similarly as we have just seen for the treatment activities, a negative reference product, and then they will allow the transfer of the mix of treatments of a waste. They will transfer this mix of treatments to the activities consuming them, so the activities producing the waste. Like any other activity, like the activities we were seeing just in the part before, markets can have different geographies. We have just pulled from the examples I have presented until now. We have Australian market, we have global markets. Especially electricity have many local markets. Because of course, as it was the case for transforming activities, different markets for the same product can be found. We can find several local markets, as I was just mentioning. In the case of electricity, with electricity we cover very well local production, so we have many local markets that are in each case covering a country or a region within a country. We have, for example, all Chinese provinces, and we will have several other countries split in provinces or in regions. And we also have market groups, which market groups is a feature developed only since version 3.2. Those are data sets that will combine markets of smaller geographic areas into a bigger one. For example, you can have the market group for electricity Europe, which will combine all the countries within Europe into one market group. These market groups are designed mainly to ease the analysis of the supply chains. If we, for example, take the example of a global consumer, and this is taking inputs of electricity of many regions, the analysis of this supply chain is much easier if you have only two market groups than if you have several national markets contributing to the electricity consumption of this activity. It's just to highlight, market groups are only created for selected products, like typically electricity, where, as I have said, it's a logical consequence. We have many national markets, and this need of then a market group to group them and ease the analysis of their relative contribution. So market groups are created only for selected products and selected geographies. I would like to insist a little bit more in the geographical coverage of markets, but also of transforming activities. The geographical coverage is very important in the version 3 because the supply chain, we are going to see in the following slides in detail how it's constructed, but the supply chain will be established based on the geographical localization or location of the market, the supplying and the consuming activities. So to ensure full geographical coverage is important. And so far, we have been ensuring full geographical coverage in the database through the introduction of global datasets. So each transforming activity will have a global counterpart, and similarly each product which will have at least a global market. And this ensures that all geographies are covered at least with a global copy. Let's go a little bit into the detail on how are the consumption mixes, so the markets, how are they generated and then used. So the linking of the supply chains will be organized around the markets and based on their geographical boundaries, on the geographical boundaries of the markets. There will exist always at least one global market per product, as we said, but regional markets will also exist when it's necessary. The market will be supplied by the producers of the same product, different technologies, in the geographical boundaries of the market. And the consuming activities, the activities that consume this output of the consumption mix, will get their inputs from the markets. From the markets that is better covering their geography. So the geographical location of all those activities is essential, and it's matching through the supply chain. Of course, direct links between producers and consumers can be used instead of consumption mix when it makes sense. Especially you, as a final user, you have always a choice between using an input coming from the consumption mix or coming from the different supplying activities. In this example, you can see when you select for barley grain in the database, you can take it from the market or from the different producers, Germany, Spain, France, global. You can take wherever suits better your needs. Let's take an example on how this supply and use of consumption mix is organized. A practical example, analyzing the regional market for electricity, high voltage in France, which is supplied by many producers. Of course, here I'm just representing the three more relevant ones, meaning the three that contribute most to the market. And let's picture a consumer, which is transport, passenger train, sorry. So how these activities are contributing to the market, how the market shares are defined. This is calculated using the production volumes. Each activity, each product produced in each activity has a defining annual production volume, meaning how much of this product is produced with this technology in this geography per year. So each activity bears this information, and using the relative production volumes, market shares can be defined. And using the total amount of the delivered production volumes, the production volume of the market can be defined as well. As it's marked in this slide, of course, these market shares do not add up to 100% because there are other producers that contribute to this market, typically imports and other technologies which are minor contributors. And as I mentioned, when it's needed, direct links can be used to overcome the markets. This also happens in the database and can happen to you as final users, as I said. Let's take the example of electricity production in the aluminum industry. This activity, it's using only the nuclear technology to deliver electricity to the aluminum industry in the region UN Europe. So this activity will be supplied by the different electricity producers using nuclear technology in the different countries integrated in UN Europe region, and this will be ensured during with a direct link. And at the same time, this activity is contributing to the consumption mix to the market in France. So there are many ways that supply chains can be organized, and especially as a final user, you have a big flexibility. So just to wrap up this section, and let's see if we have some relevant questions. Market activities are consumption mixes where transport information and losses of the product during the transport have been added when relevant. Markets link together producing and consuming activities in the geographical boundaries that they are describing, and when needed, the database will link together directly producers and consumers of a product. And as a user, you can always choose between the outcome of the supplying activities or the outcome of the consumption mix, the market. So it's fine. We don't have any questions, or I think we can.
Well, Emilia, you have one question, which I actually go through it. It's the question is one of the users. They ask, is allocation of products possible, like two different outputs from the same data set? Well, I think I answer on behalf of, we will actually be explaining the system models in the next part of this webinar. That is also a set of rules to how to deal with byproducts, including allocation. So I think the next part of the webinar will answer your question in more detail. And apart from this, yes, that there's no more question actually.
Okay.
Please.
Then let's jump to the last part of the webinar, which is understanding the undefined database and the different system models that ecoinvent publishes. So this is exactly how version 3 works. The version 3 is based, the data is gathered, it's collected, it's maintained, and it's updated in the form of multi-output and linked uniprocesses. What does it mean? That means that they are physical description of processes, and they will contain information on what is the main product of the process, but also what are the co-products. Everything will be modeled in this multi-output and linked uniprocess. The collection of those uniprocesses is what we call the undefined database, and this is what is accessible for free in our web page for anyone that connects and that log in as a guest. To that, we apply different linking rules. Different linking rules meaning linking algorithms that are representing that allows us to calculate different modeling choices concerning allocation problems. So what do we do with co-products? Do we allocate? Do we use substitution? Modeling choices regarding what do we do with recycling products and with wastes? How do we handle constraint in suppliers or in consumers, etc. So those modeling choices, they will be coded into linking rules, and those different linking rules will be applied into the undefined database. And this will result into single output linked uniprocesses. The uniprocesses will not be any more multi-output because we have already taken the decision of allocation or substitution, so they will be single output. And they will be linked because they will be interconnected one with the other, forming the supply chains in different ways depending on the modeling choices we would have taken. To that, we will apply matrix inversion, like always, and we will produce the LCI data. And then, using the different impact assessment methods and the relevant characterization factors, we will produce the LCIA results. The collection of LCIA results, LCI data, and UPR is a system model. That means that for every set of modeling choices we have taken, for every set of linking rules, we would have one system model. So we would have system model X, Y, and Z, which is exactly what we have now in the database. We have one undefined database, as I said, freely accessible for everybody, and we have three system models, which are called allocation, cutoff by classification, allocation at the point of substitution, or APOS, I will call it APOS from now on, and substitution consequential long term. In the case of the undefined database, this is is collecting, as I said, the unallocated multi-output activities. This is a very nice thing to check if you want to dig in how things are modeled, where the wastes are produced, and you will see the physical description of the activity, meaning the wastes will be on the output side, etc. So really check that if you're trying to also if you're thinking, how can I model this other process that it's not in the database, you can check here. You can check for similar activities, and you can already start digging here on how would you do your own modeling. This is only available in our web page. And we have also a new feature, which is this advanced search in the ecoQuery in our webpage, and this allows you to search by product or activity name, but also you can do specific sectorial searches. So now it's the search within the database is very powerful with this feature. Okay, let's try to present the undefined database and each system model in short, and then I would go and give a little bit more of detail. So again, the undefined database contains the multi-output and allocated unit processes. As I said, it's useful to check the modeling and the physical description of the activity. And if you're trying to see how to model a new product not existing in the database, like the question in the beginning of the in one of the parts, like the black liquor, well, try maybe to find similar activities in the database, and you can start getting your modeling bones there. Then the three system models, I start with a consequential here. Consequential is applying substitution at the primary production level. Only the marginal suppliers are supplying the market, so the most adapted technology to the needs of the market. Those are the only ones that will be feeding the market. And it will consider constraint by products. It will consider cases where you actually don't have an unconstrained supplier to the market, but you have a marginal consumer that will model, that will apply a shift in production means and will be able to supply the market. We have then here together the two allocation system models, APOS and cutoff. Both apply economic or physical allocation. And the difference is that in APOS, the commercially valuable products produced out of treating wastes, for example, electricity or heat, will bear the allocated part of the burdens of generating those wastes and also the allocated part of the burdens of treating those wastes. This is done because the system applies a small system expansion. In cutoff, again, allocation will be the same, economic or physical. There will be a classification between ordinary byproducts and then waste and recyclable materials. Recyclable materials will be available burden-free, but wastes will bear the burdens of treating them. And the useful products that will be produced out of useful or ordinary byproducts, in this system, that will be produced out of treating waste are supplied also burden-free. So as I have, you have already understood, there are two big set of differences between the system models. There are two big decisions that you have to take when you are defining your modeling choices and your system models. One is, how do I deal with byproducts? And the other one is, which producers are supplying my market? Which producers are supplying my consumption mix? How to deal with byproducts? We have allocation or substitution. And allocation, we have two system models, as I have just mentioned, the cutoff and the APOS. And substitution, we only have one, substitution, consequential, long-term. In the other kind of decision that we have to take, which producers supply my consumption mix, we can have average suppliers, meaning all the suppliers feed the market, or marginal suppliers, meaning only the unconstrained supplier, only the technology that can adapt to the market needs is supplying it. And in the first case, we have the two attributional systems, so allocation cutoff and allocation APOS. In the second case, we have substitution consequential long-term system model. Let's start by the second part, which is to distinguish, how do we distinguish between what is an average supplier in one system model and what is a marginal supplier in another system model. So how do we do that? First is that we have to set the constraint. We have to have a way of identifying whether a supplier is average or marginal or whatever. And for that we use the level of technology. So we have defined 5 levels of technologies that you can see in the slide, from outdated to new. And each of the activities in the database will have a level of, will be identified or will also have the characteristic level of technology. You can read what each of those level of technology means. I will just highlight that modern is the most competitive technology in a growing market, and old is the least competitive technology. And how do we do so? The level of technology can determine what is a marginal supplier in Consequential. So what we do is that we will cross the information of the growing rate of the market. So if the market is developing, as you can see the arrow, it's a developing market, then the marginal supplier will be that is able to adapt to the increasing demands of the market. So normally the modern, the most competitive technology, and if not, current. And if we are thinking about a shrinking market, which we don't have in database, then it's the other way around. So it will be the least competitive technology, the one that it's dismantled first or outdated. That means that if we go back to the example of the market for electricity high voltage in France, and we again list the 3 main contributors to this market, nuclear, hydro, and natural gas, those activities are identified with its level of technology, which in the case of nuclear and run-of-river is modern, and in the case of natural gas this is considered to be current. So in the attributional perspective, for both our allocation system models, whether APOS or cutoff, in both cases this is not relevant. All suppliers are supplying the market, as you can see here, regardless the level of technology. So this is how it works in attributional. But in consequential only the unconstrained suppliers, the marginal suppliers, those that will be ready to increase their production if the market needs so, only those with the modern technology in this case are supplying the market. And this third one, that in attributional, as you just saw, was supplying the market, it's not anymore. So that means that the market composition is different in attributional or in consequential linking. So that sets this first big difference in the modeling choices we are taking. Let's attack the second big difference on the modeling choices, which is how do we deal with byproducts. How were we dealing with byproducts in version 2? I asked to those of you that are experienced users of version 2. In the version 2, byproducts were informally classified in 3 different classes. Byproducts that were allocated as co-products, recyclable materials that were cut off, so they were not listed in the datasets, and wastes that did not exist as a byproduct, but as we have seen, they existed as a product of a treatment service, as an input. Any byproducts of the treatments were normally cut off, and this generated quite some problems. First is that the boundaries between different classes was not clearly defined. Then that the transparency was lost due to missing flows, all those flows that you decide to cut off because they are recyclable materials, and then you make it impossible to mass balance the activities. So let's start analyzing in detail how do we deal with byproducts each of our system models. And let's start with the one that we recommend to start working with. If you are an experienced user of version 2, we recommend this one because this is following the modeling decisions of the version 2 but applied in a consistent and systematic way. And if you're a new user to version 3, also because the results of this system model are the easiest to analyze. So we really recommend you to start with this system model, allocation cutoff by classification, which in some LCI tools have a different name, but this is a different problem. So in this system model, there is no cutoff within the activity, there's no cutoff within the inventory. All co-products are considered in the activities. There's a completeness in the inventory. The cutoff will happen during the construction of the supply chain because the products will be classified differently, and then allocation will happen differently depending on their classification. Let's see that in depth. In order to construct to calculate the allocation cutoff system model, each product in the database has a classification. It's classified in 3 classes: ordinary, byproduct, recyclable, or waste. This is a classification that can be checked if you search for a product in the database in the ecoQuery or in the different tools or supports that we provide in the database. You will see that associated to the product is its classification. This product level classification will determine how the byproduct will be allocated in the system model. Ordinary byproducts will be allocated differently than recyclable and waste products. How can this possibly happen? So let's take an example. Let's take this transforming activity that it's producing products A and B, and it's also producing a waste and a recyclable material. Products A and B being just ordinary byproducts. What will happen is, first, as we have seen, the waste and the recyclable material, those are products that will need a treatment, or maybe a disposal for the waste or a treatment for the recyclable material. They will be moved into the input side with a negative sign. This maintains mass balance, as we have seen already, and allocation will happen here between the product A and product B. Let's just focus on this product A. So let's just focus on this part. The recyclable material will be supplied. I'm in purpose ignoring the market, so I'm just showing I'm showing a summarized version of the supply chain. So the recyclable material will be supplied by burden-free activities. So those are activities that are just supplying this product to the demanding activities but are empty. So here is the point of cutoff. Here is where cutoff is happening. And on the other side, wastes will be the waste will be linked to the waste treatment supply chain. So waste will be burden-free. So waste will be fully burdened. So this transforming activity will bear the burdens of producing the waste, but will have the input of recyclable material burden-free. If any ordinary byproduct is produced in the waste treatment, it will be also burden-free. And so here is the point of cutoff of in the case of the waste. Let's jump into the other, or maybe we can stop here. Do we have any question that we could take now, or shall we continue to the next?
We have one question that I actually saw a few minutes ago, which was asked I think 20 minutes ago. So it's basically related to the previous discussions. Maybe we wait and we answer all the questions at the end.
Great. It's just in case there were burning questions on allocation cutoff.
No, there's no specific question on this. We have 2 questions that we, at least for now, that we'll answer at the end of the webinar.
Great. Let's keep on going. So let's move then to allocation at the point of substitution, which, as I said when I was introducing the system models in short, will apply a small system expansion. Here, there's no distinction between waste or recyclable material, but the distinction is applied between products that would need further treatment in order to become what we can consider commercially valuable, and products that don't. So if we take a similar example as we were taking before, an activity that it's producing product A, and then municipal solid waste as an example of something that it's clearly need to be treated. The first thing that would happen, as we have seen now many times, the municipal solid waste will be moved to the input side with a negative sign. This is maintaining mass balance, nothing new. Then we will have to connect the treatment of the municipal solid waste with this activity demanding this treatment. So this will be done, as we have already seen, also nothing new. And then we will have in this municipal solid waste treatment probably some product that we can consider here as commercially valuable. We can imagine that municipal solid waste is incinerated, for example, and it's generating electricity or heat. So what do we do with this product? So as the name of the system model says, an allocation will happen, and it will happen at the point of substitution. And where is this point? We can set this point at the place where the first commercially valuable product will appear in the supply chain, so here. So what do? We will apply small system expansion, and product C, which is produced out of treating the waste, municipal solid waste, is allocated here, where actually municipal solid waste is originally produced, in the transforming activity that generates the waste. What does it mean? It means that before allocating, we are combining the impact of producing an activity that generates a waste and of treating this waste. So the impact of the activity that generates the waste to be treated and the impact of the activity of treating the waste will be together shared between all commercially valuable products produced in the value chain. And in this example, the value chain was simple, contained just one treatment activity, but the value chain can contain a treatment chain, so potentially several commercial byproducts. So this system model, allocation at the point of substitution, is very interesting in certain scenarios, gives interesting results, but as you can see here, can be sometimes a little bit tricky to analyze. So you can have a value chain which is complicated with many treatment chains involved, and then you will have to devote some time in order to understand the results. And let's just end briefly with the last system model, which is substitution consequential long-term. In this system model, as I have just mentioned, byproducts are treated by substitution. So here let's take maybe a real example, or an example not with product A and B, but with real products. Let's take a market for meat and two transforming activities, a meat producer, which is producing meat as the main product, and another activity which is producing wool as a main product, and meat as a co-product, which is sheep production for wool. The first thing that one has to understand is that only the meat producer will be supplying the market in this system model. Only this is an unconstrained supplier. This is what is designed as a marginal supplier in the consequential system model, and this other one supplier is constrained. It's not supplying the market of meat. This other supplier, it's only contributing to the market of wool, which is the main product of this activity. So the meat, in this case of the sheep production for wool, will be moved again to the input side with a negative sign. So everything okay for mass balanced. But here, this sign will have an effect on the supply chain. This negative sign does not have a matching negative sign somewhere upstream in the supply chain. So the effect of moving the product here is different. And let's see let's see what the effect is. This negative sign will be able to, I have a problem, no, yeah, in my PowerPoint, yeah, everything blocked. Yeah, I need to I need to restart again. So I leave you with Amir. Will I do this?
Okay, sorry for this technical problem that we weren't expecting. Maybe in the meantime, I would actually go through one of the questions and I try to answer them. So we have a question from one of the users which actually asks, for non-European countries, what would you suggest LCI practitioners to do for regionalization while the regional datasets are not still available? Should we use the global datasets, or what about the cases where we need to model more specific production processes? Should we keep using version 2.3 without market activities until more data are available? So I have to say that firstly, I mean, the introduction of markets into version 3 does not change the results or the impacts of different processes basically. So that has nothing to do with the modeling part. So for the last part of your question, I think it's a bit out of scope. But in terms of regionalization, I think this is a very more general question. So firstly, I have to say from our side, of course, we know that our data are more European representative. That's why we are expanding the scope of the database, and the SRI projects is one of the one of the projects we have to expand the scope of the database to include more regions. So from our side, just to say that we are also trying to address this problem. From a practical point of view, and again, this is a bit out of scope of this webinar, but very generally speaking, of course, we would suggest, of course, if there's no data regionally available, to use the global data and try to regionalize it. For example, focusing on the main flows, and maybe you could do a screen LCA to see what are the flows that contribute more to the impact of the global data sets and try to replace them with the regionalized one. For example, the first case that immediately comes to mind is the case of electricity and, for example, transportation, which there might be national statistically available data to replace the global. So basically use the global data set that ecoinvent has, or another data set that you think is more appropriate to the case of the region you're talking about. So we call them the proxy data set, and you try to adapt the most important flows, at least on the first phase. That is the most viable solution that comes to my mind at the moment. So I think I can leave it to Emilia if she can complement this, and also leave it to her to continue with the webinar.
I just want to complement a bit on Amir's answer, and to mention that because of this structure of constructing the supply chains by making the producers stock with the consumption mixes and those stock with consumers, and based on the geographies, that means that the supply chains will get richer in the more they get richer in local data, the more adapted to local circumstances the supply chains get. When a new activity is modeled in a new geography and a new market in this geography appears for it, it will start drawing a supply chain. So I totally agree with Amir. The more we will enrich in local data, the ecoinvent database, the more the supply chains will be accurate for local studies, and this can happen step by step because of the way we construct the supply chain. So we can enrich in the production side, and little by little enrich through the whole value chain.
So since we are in the question and answer phase, we actually have two more questions from users. So one of them is that they're asking, it's about the treatment activities. So they are asking, when the negative sign is used, the impacts wouldn't change. So isn't the impact still the same even when the negative sign is used?
Yes, exactly. That's a very good reminder. I have mentioned it when I was explaining how the treatment chains get constructed. Yes, the fact of using the negative sign is only allowing us to link the treatment chains as we want upstream of the waste producing activity, and we can ensure mass balance in both the waste producing activity and the waste treating activity, and that's why we use the negative sign. The negative sign is by no means affecting the results of your LCI A. So you don't get a change in the sign of your results of your impact assessment methods. This negative sign does not contribute to that. It's just modeling a mass balance activity, basically. It's just helping us to maintain mass balances. It's a mathematical trick for that.
Thank you, Emilia. We actually have one more question, which I'm not sure if it actually is related directly to the scope, at least for now. Maybe we should ask the user to contact us. But so they ask, can we somehow estimate the accuracy of the LCI study when we are using the global data sets instead of local?
Well, yeah, this is. I guess that it's you can start using global data if you don't have local data accessible, and you can start comparing and start measuring the accuracy the more rich local data you get.
I would just add also to this that the idea of the uncertainty, basically the uncertainty analysis, the pedigree matrix that we have as a part of any data set would help you actually to assess the uncertainty. And we have a few more questions, but I think it's a good idea if we actually continue with the webinar right now, exactly, because we're running out of the time. So for the rest of the questions, I actually write the users and ask them to contact us directly for the support. Please, Emilia.
Okay. Done. So I will maybe move a bit backwards because this is a not so easy topic, and we were interrupted somehow in the middle with PowerPoint updating, I don't know what. So we were looking at this example of meat and wool producers. So let's go even one back. As we said, from those two activities producing, one is meat as a reference product, the other meat as a co-product. Only this one is what we consider the marginal supplier, the unconstrained supplier that can supply the market meat in the consequential system model. This other one is constrained, and it's not supplying the market of meat. And it has this negative sign, which has allowed us to move it from the output side and maintain the mass balance. But as I was saying, this negative sign has other effects in the supply chain. This negative sign is representing a reduction in the supply from the marginal supplier to the market. So what it means basically is that if we need an increase in meat production, it will be only the marginal supplier that can respond to it. It's the only one supplying really the market. But on the other way, if we need an increase in the wool production, that will mean an increase in the meat production here in this activity, which is producing wool as a main product. And this meat will displace the meat produced from the other activity, so reducing the needed supply from the marginal producer. There's specific type of byproducts that I will just explain a bit briefly, which are byproducts that need a constrained market. What that means, a constrained market will occur for byproducts that cannot be substituted using alternative production routes. Like in the example we have just seen, we have the meat that was produced as a co-product in the wool production. But there was also a meat producer, which was the main producer, the marginal producer of meat. But there are cases where this cannot happen. There's not an alternative production route for those byproducts, but still, those byproducts will have a demand that it's not implying further treatment. They are really what you would think as commercially valuable. And an example of that is sodium hydroxide, but I will not go into details. In those cases, substitution will apply by reducing the use of this product elsewhere in what it's called a marginal consumption activity. And this marginal consumption activity will be the one that will be capable of doing this substitution, because it will be capable of changing to an alternative mean of production, so reducing the need of this byproduct. Just to finalize this part and then go into the small wrap-up. This is a general question we have many times. Why do my results differ from the results I had in version 2.2? Well, first, please consider that we have done a big update, many updates in datasets, in data. We have more data and more modern data. For example, electricity is the most obvious example, and these do modify the results. We have also corrected the allocation approach. In some cases, in some products, we respect very much the ISO hierarchy, and we have changed in some chemical cases, for example, we have changed the allocation approach. We have also updated the default transport distances. This is now done using a systematic approach, so this can also change some results in some value chains, and we now do consistent generation and consistent use of consumption mixes of the markets. So those are four fundamental things already change a lot the results, or can change a lot the results from what you were used to get in version 2.2 to what you can now get in the for example, cutoff system model, which will be the one to compare with version 2.2. Just to wrap up this part, and in general to finish with my contribution to this webinar, the generation of the database as unallocated unit processes allows the construction of several system models based on the same data, and as well an easier update of supply chains. The construction of a system model is based on the definition of modeling choices coded in the specific linking rules. 3 system models are available in version 3.3 for license holders, and the undefined database is available for free to everybody. And you have to choose the system model that best fits the goals and scope of your study, and we can help you understanding what the system models are, but it's for you to decide when to use one or when to use another. And yeah, thank you very much for listening. I don't know if we have more questions to finish. Okay, so yeah, as Amir said before.
No, actually we don't have any questions, at least at the moment. Maybe you should just wait for 1 minute, because I'm receiving some
okay.
Thank you from people, actually, just appreciation. Okay. Maybe some people are also typing questions. We have still a few minutes maximum to receive questions, so if you're, we will be here for at least 30 seconds more, yeah.
I mean, otherwise you can always write us an email. I think you have both our emails in the presentation, and we can answer to any other questions you might have. So with this,
I think we should close this. Yeah, I'm not seeing.
I would say yeah, I would say goodbye. Thank you very much for listening. It was a pleasure to get so many questions and an active participation. It's always nice. So thank you very much on my side, and yeah.
Well, thank you from my side also. As Emilia said, any specific questions regarding the webinar, please send it to us. We have also recorded the webinar, and we'll provide the link to the recording as well as the presentations as a follow-up during sometime next week. So thank you once again for attending the webinar, and have a good weekend. Bye.